Thank you. Yeah, I'm also hungry, so let's speed this up. Airgapped Kubernetes is a topic in our company or for our customers, and this talk is kind of a condensed version of conversations we have with different customers and kind of trying to illustrate you kind of why people do airgapped and run Kubernetes in an airgapped way, also taking away the fear to run Kubernetes airgapped, and some more details along the way. This is supposed to work. Oh yeah. So exactly, so there are benefits of running Kubernetes in an airgapped way. You might start the journey with thinking, okay, I have this requirement, but even if you don't have, maybe at the end of the talk you take some things with you and apply them even if you don't. And I would argue that more naturally at some point maybe you even evolve your architecture to it. What is it? Let's find out. So the word itself implies that you want to actually put a physical gap between your systems, in our case, networks. In the last kind of days and years, it gets not really that strict anymore. If you have a firewall around your network and limit the access to that network, you could argue it's kind of air-gapped. So there's not a physical air gap anymore, but you limit it, and it just describes a network which doesn't have access to the internet for many reasons. And it comes in different flavors, but let's focus on the most strict one where it's completely blocked and there's no access to the outside. You could argue that maybe it's already air-gapped if you allow it to a certain allow-listed set of repositories, or if you say at the beginning of a provisioning flow there is access and then it's completely shut for runtime. But I think we can ignore that for now. So what are the reasons to run airgapped? Why would you do it? Security obviously also touches into compliance, but stability and performance is one of those gains I mentioned at the beginning you could take from it, also performance-wise. So you want to reduce the attack surface to your system, right? You don't want to have people access to your network. You don't want to allow any download from malicious code into your system. You essentially want to download from trusted stores only, or trusted sources. If you care about uptime, if you have lots of nines, then you cannot trust all the repositories. Also, maintainers might go rogue or some repositories get hijacked. So you really need to take care of that and make sure that that's taken care of, and ideally within your security boundary. Already mentioned performance, so think about all the data which needs to be downloaded and transferred through your networks. That can add up. If a company decides to change their quota and you usually downloaded all of your Docker images from that company, which name I will not name, then you run into problems, right? So surprise, quota, and nothing works anymore. Yeah, and compliance reasons. Compliance is always boring, so I'm skipping that. It's not boring, but yeah. So let's look at a typical Kubernetes installation. At the very beginning of your Kubernetes journey, you start with a set of Kubernetes nodes. You're installing it the hard way, and you download from the internet. What are the resources you don't usually download stuff from? If you're using Ubuntu, it's an apt repository, usually then binaries from GitHub, and container images, OCI images. And at that point in time, it's manageable, right? Like it's a few of those repositories, few of URLs to manage and to look into and allow list perhaps, but that can grow. So our customers typically have a quite heterogeneous set of setups. It's not only one provider, or hyperscaler, it's many of them. Different operating systems, different combinations of CNI and CSI and so forth. So there's really like a lot of stuff which can be installed on your node. And then at the point of time, it's really crucial to be aware of that. So you cannot leave your devs just download anything unchecked. And you need to be aware that everything comes from a really diverse set of repositories or sources. So now you saw why and what it is. How, though? How would you do it? And I want to go into a little bit of detail. It's not like really in-depth one description of one tool and how you would set it up. I try to be kind of agnostic here. So try to really control your sources. I think that's clear by now. I'm kind of repeating here and stress it. Use one of those tools like JFrog. They have a booth here. Talk to them. And Nexus was a great harbor if OCI is enough for you. And make that, if it's not already a part of your enterprise architecture, it will then become a important part. Then use that as your source of truth and a way to allow list. Make sure that everything is pulled only from that artifact store, and you're basically already set in that regard. Because if you configure everything to only download from there, this is then the place where you can configure and allow list, an extended allow list when your system is growing. Exactly. Also, all of these registries, they have vulnerability scanning in place. It's a way to store your own in-house software. So it makes sense to have that in your architecture. I would argue that pre-baking your images in Airgapped is not always the best, or in our cases, when we talk to customers, we kind of argue against it. I know that in the Airgapped Kubernetes environment, pre-baked images are suggested a lot. But I would say, don't waste your time at these stages in the beginning when you pre-bake your images. For some certain common denominator topics, certificates of your company, for example, that would make sense. But remember the case where you really have a heterogeneous setup. This can add up, and it can become quite messy. And much rather think about the provisioning steps. The time in the whole journey just before a node gets provisioned. This is where you make decisions of what CNI needs to go on that node. Does the containerd in what version, and so forth. So this is the point in time where you have all this configuration together, and then you render let's say, cloud init from it and provision your node. So you know that's the place where you will have some conditionals, some logic. So embrace that and don't focus your time on pre-baking images. Yeah, storage and traffic. If you need to then transport these images all over the place, that can also add up. Could be an edge case, but yeah. So how do we leverage this? So I guess really simple installations, really CLI-driven installations of Kubernetes. You would use some initial bootstrap script, and that's fine, right? Like you use Terraform, for example, you can insert a cloud init into that and scale your nodes up. That's already fine. And there you have the power to basically override all the URLs, and that is the place where you point it to your artifact store. Quite simple, actually. If you have needs to automate this much further, if you want to have auto-scaling, then you need to look at things like Cluster API or KKP. If you're interested, talk to us at the booth. With Cluster API, there comes the idea of a machine controller. And the machine controller is in charge of actually having provider knowledge and knowledge to talk to providers to provision nodes, but it needs cloud init or cloud or ignition files to provision those. And this is where, in our case, in our suggested architecture, OSM would come in as a templating engine. So there, what it spits out is basically a cloud init just before you are about to provision your node. And this allows you to be super flexible during the lifetime of a cluster, even change it. And then the next time a node is provisioned, it's having this new configuration. Yeah, and this kind of, there's much going on here, but this tries to illustrate what I just talked about. So ideally, you would have a template, a templating engine, which at the end spits out cloud init or ignition files. You have your provisioner in place, which then takes it, talks to the provider, and provisions it. And the good thing then is really here you have a central source of truth for how to configure it and how to make sure that it's pointing to your central artifact store. And this is a cloud init file. If you never saw one, it's not super interesting, but what's going on here is that cloud init comes with modules for example, in this case, it's a rel image I want to configure, so I need to take care of YAM repositories. What I do down here is I set all my YAM repositories to my archive URL, and then I need to disable the default registry. And after that, if I do a YAM install in line 14, everything is pulled from my central archive. So this would be basically the step for these kind of setups. And what do you think is also important in that step? Who thinks like something is missing here, something which needs to be put into these templates? What's important to boot or to make a node join a cluster? Anyone? Yeah. Yeah, like a token, some way of authenticating to the Kubernetes API, exactly. So you could make this super static if you are at the beginning of this and you don't want to have a template logic or anything. It could be fine to have a static cloud init, actually. And since we're in Airgapped, maybe you are fine with having a not expiring token. You could put it into there. Because at some point you want to make a make the node join, right? You need to have that call where it's then doing the whole dance. And this is also now we are done with apt-get, YAM, all of that. What about the container images? ContainerD has a nice feature, the mirror feature. This allows you to say, I want to override the registry part, the beginning of the URL of my images, and replace that with something else. In our case, our central artifact store. This is how it looks like right now. Officially, this is deprecated structure. In version 2, it will be looking different, and it would not fit as nicely in 6 lines of code anymore, so I stick with this. But you're most likely using this version right now. And that's it. This configuration means wherever is downloading an OCI image on my nodes, if this configuration is in there, it will instead go to my container registry and pull it from there. So this already gives you or enforces enforces it. And you can bundle this really nicely with another feature the big artifact stores like JFrog and Nexus are offering, and that's the group repository. What's really nice here is that if you think about like the different OCI registries you're usually pulling your images from, you would need to configure, like a block for all of these. But you don't need to. You can bundle all of them together in a group repository, so you configure each of them individually as proxy repositories. Nice benefit is that you most likely already have an internal repository where your dev's pushing OCI images, or your CI/CD is pushing images too. And then, at the end of the day, you add a group repository and make all of them available behind one single URL, which you then can put into here. So this configuration plus that group repository feature allows you then to make sure that OCI images are always centrally sourced from your local artifact store. And now I need to drink. Sorry. They're still doing it. It's perfect. Thank you. Yeah, Airgapped architecture. You saw the drawing in the bottom. But now together in the middle, there is the central artifact store and all the remote sources, let's say. I would argue that this is already really good, right? Like it's not like you could say, where's the air gap? Where like it's not completely shut down, but you isolated is really already to a really good degree. So down here, nothing can reach the internet directly. You can only reach your artifact store, and that's it. And then it's quite nice that the artifact store already can pull from the internet. That's fine. But if you have requirements where this is really not possible, where someone says no, then it's still quite doable. There's a way of replicating it. In case there's an error use case, for example, you could have tooling which exports Docker images into a tarball, and then you take it on with a USB drive to the basement and load your artifact store. So I think what I just want to say is that in these cases, it's still probably beneficial to have a local artifact store to manage this. The way you replicate that could differ then depending on what's possible in your setup. So Nexus, JFrog, all of them also Harbor, they have nice replication functionality. So if there's some way you can connect them, then that would be nice. If not, then this arrow there means there's a person working with a USB drive. So looking at the clock, there's still some time left, but mostly at the end of the talk. So please remember, Airgapped has many benefits, even if you don't see that requirement yet. I think it has quite many benefits, as I pointed out. It becomes a must for really big installations if you are concerned with reliability and performance. Don't waste your time pre-baking too much. It's also, I never enjoyed it, and much rather focus on your provisioning. So make your provisioning logic as flexible as possible. All the gains from there. When you change versions, when you need to fix something in the run, you have gains from that. And use your artifact store. So it has benefits like vulnerability scanning, signing, and all of this. And that's all I have. Thank you.
Super, thank you. And then I don't think anyone is angry with you if they can go to lunch a little bit earlier. But we do have a couple of questions, and if you still have a question, please put them in. Let's see if we can get them up on the screen. Excellent. Do you think creating a group of repositories, I guess, with all the upstream repos creates security risks? Better copy only a bunch of trusted images? ?
Yeah, that's a good point, actually. That I think you can still do. I think there's still like a limitation, or like you can limit it down to some images, but that's something I need to, I take it with me, and that's a good point, actually.
And then next year you'll give a talk about how you've tried it, and then
exactly.
you figured it out. All right, which one do you want to take?
Maybe from the top. Is there Kubernetes way to configure cryo container mirrors like
OpenShift does? Just finishing the sentence.
I mean, I'm not familiar with the way OpenShift is doing it. I mean, I showed how the containerd configuration would look like on the host itself. Depends on the tooling you're using, how this configuration actually ends up on your node. So if you're using KKP or a Kubernetes platform, this is handled. So if you're provisioning nodes, then the templating engine, OSM, actually takes care of injecting that mirror configuration out of your configuration file into the nodes.
Thank you. 2 more?
Yeah.
How do you manage the certificates when mirroring containerd registries?
So I guess that's certificates as in authenticating against a repository, because that's also doable. That means there's more configuration you need to put into the containerd configuration if that's necessary, or you can hide that at the mirror usually. Sorry, at the proxy repository.
All right. What happens with a cache of images on a node? What if in the cluster registry, the sentence is excellent. What if in the cluster registry doesn't work on its own? Do you get it's like?
Yeah.
Do you get what they're saying?
Nothing changes in that regard. Like you're still pulling OCI images from a registry, right? It's really just a layer between. If it's down, sure, it's down. Like there's no way to pull it anymore. There's no benefit, right?
Right. Well, thank you very much. Let's break a little early. If you still want to find our wonderful speaker, you can find him here.
Thank you.